This is the video record for probability and stochastic process course homework 9, problem 3. And we know the problem setting is if x of t is the portion process with p of xt equal to k is equal to e to the degree of lambda t times lambda t to the degree of k over the k exclamation mark, we need to prove that the limit where t is approaching infinity of xt over t is equal to lambda in probability. So for a portion process x of t, we get the expectation of x of t is actually equal to lambda t, and the sigma square of x is actually equal to lambda t as well. And we know by Chebyshev inequality for this process of a binomial distribution for any sigma which is like a small number larger than 0, we always get the probability of x over n minus a mu. We also take the absolute value of this number where it is larger than or equal to sigma. The probability is less than or equal to sigma square over epsilon square. And if we take the limit of this equation on both sides, we can get it like the left hand side of this equation where we reverse the inequality sign and get it to be larger than and get it to be larger than epsilon, we can get the value of this probability to be larger than epsilon is equal to 0. And since portion distribution can be always seen as an extreme situation for binomial distribution, and the difference of these two distributions is we only divide the time interval t into n segments of delta t, where we can see it to be like extreme situation for the binomial distribution. It can be seen as a portion process, and then we can know that this lambda is taken to be lambda equal to alpha t, and it is also equal to n alpha times delta t, which is equal to np. And we also know, as I previously described, this epsilon square of x is equal to lambda. So the probability of this absolute value of x over n minus lambda, where it is larger than or equal to epsilon, is essentially less than or equal to sigma square over epsilon square. And similarly, we also take the limit for both sides of this equation, and we can get it when n is approaching infinity. The probability of x of n minus lambda absolute value, it is less than epsilon, which is like a very small number, and the limit of this is equal to 0. And it also means that the limit of this absolute value is less than epsilon is essentially 1, and it just means that it's like 100% that x over n minus lambda is essentially approaching to 0, and we can actually get it to be the limit of x of t over t is to be lambda, where we replace the n for a number time interval t. So roughly this can be proved that this equation is valid in the probability case. This is the end of this video record.